Hello everyone. Hi, my name is John Watson and welcome to a new series type of presentations we're going to be giving. This is the Team Up and Train series, and my name is John Watson and I am the Senior PCB Engineer at Legrand Corporation North America. I work in the Building Control Division, where we basically produce products that control buildings of lighting, data, power, different things like that. I direct the PCB teams there of basically teams that are around the world of about 60 designers now. And I've been a part of PCB design for about 20 years. Been in electronics for about 40 now. And it is a pleasure to be with you today. And wherever you're listening to us, welcome. We're going to spend the next couple hours just kind of chatting and giving you some great information. I want to give you a heads up though on some other great speakers that are going to be following me here. We're just clearing our throats here. We're just getting warmed up. And we have a few other people I want to introduce you to. And one of those is Rick Hartley. He is going to be presenting also. He is going to be talking about how to achieve proper grounding. And there's also Mike Creedon, fantastic gentleman. Please get to know him, applying the knowledge for EM fields with high-speed design routing principles. And last but not least is Susie Webb. She's going to be covering the designing the signal return paths through your board. These are some phenomenal leaders in our industry. Understand, I am a PCB designer just like yourself probably, and it's a pleasure to be here with you today. Just know that these other speakers are going to be coming up behind me and sharing also. So please take the opportunity to grab their presentations and listen up, okay? So how many of you guys have seen this? This might be an unusual place to start our conversation, but this here is the beautiful 2020 Corvette. It is beautiful, and I can tell you that it is gorgeous. This is a beast. It's got it's a 6.2 liter V8, 500 horsepower, 470 pounds of torque at 5150 RPMs. This is a monster. And the statistic that really jumped out at me when I came across this was the fact that it goes from 0 to 60 miles per hour, 0 to 60 in 3 seconds. Think about that. 1001, 1002, 1003. From a complete stop to 60 miles per hour in that period of time. That's a pretty amazing. And I just wondered if there was like extra insurance that you need for the whiplash that you get for something that takes off like that. That is phenomenal. And I can tell you that that is a lot of power backing you there. But you actually have to work through 8 gears, I have to say, to get there. That's why they call it the C8 Stingray. You have to work through 8 gears. You start at gear 1 and you work through, and as you're shifting gears, you get more and more power, and you're going faster, and you're going down the road faster. But my question for you is this, and something I want you to ask yourself is, what if we never shifted out of first gear? What if we never shifted that vehicle out of first gear? We're not going anywhere. We're going to be still sitting at the light. You're going to hear the engine revving up, but it's not moving anywhere. You see, a lot of times we have so much power behind us, and we have so much so many tools that we have available to us that a lot of times we don't use them. And that is probably my point on this, is that I know a lot of designers that I've worked with and I've met that do not use the tools to its abilities. either they're stuck in a rut or in the way they used to do it or the way they've always done it, and they've never changed out of that. They've never shifted their gears. I've known designers that have sat and they basically don't know about the tools that are available to them or the power that's there for them. Let me be very frank with you, okay? Altium is our car. Altium is our 2020 Corvette. And what we're going to be talking about today is shifting the gears in your use of Altium. You could be a brand new user or a seasoned vet. But all of us are at a point where we need to shift our gears. We need to change sometimes how we do things. And we are constantly need to stay on that cutting edge. I can tell you that the industry is demanding for us to do that. The industry is demanding for us to stay on the cutting edge. The industry is moving at a breakneck speed right now with innovations, changes, different ways that they're approaching things. And it is going to be our responsibility as designers to keep up with that. Otherwise, we're just going to be left behind. And I'm going to be talking, sharing with you a lot of stories and different things like that today about how I've seen in the industry some of the young people that have grasped onto this mentality of shifting their gears, that they're never satisfied where they're at. They always got to be learning the next step, the next stage, the next thing to learn, and pressing on to new things. I think a lot of times it's it's people like myself maybe that have been in the industry for so many years that get very lackadaisical. We get lazy, we get apathetic, and sometimes we just stop learning. And we're going to talk about that also. And I'm hoping that through this presentation, I'm going to give you kind of the tools and the challenges that we're facing as designers, and that we will be able to basically give you the answers to your issues. So our industry is demanding for us to shift gears. Back in 1965, the Goddard Space Flight Center in Maryland actually bought this computer. It was used to put the first man on the moon. Now, this was the IBM System 360 Model 75S. And I can tell you that it was the cutting edge technology of the time, all right, 1965. It had 512 bytes of core memory. It cost $3.5 million, and it was the size of a car. And I don't think I'm talking about a Prius here. I'm thinking a very big car, maybe a Cadillac or something like that. All right, this was not a small little thing. This was a major piece of equipment, but it was the cutting edge technology of that time. Jumping forward to November 2017, iPhone 10 was released. That's 2 years later. Let me show you something. The iPhone 10 has a size of 5.65 inches, 2.79 inches. It has 64-bit ARM V8A 6-core CPU. It has 4.3 billion transistors in it. The neural engine does 600 billion operations per second. It has 3 gigabytes of RAM with additional storage for 256 gigabytes. That's amazing. You're holding in your hand 100 times more power than you did in the first computer that put a man on the moon. And that's the direction we're heading. Things are moving forward in that way. But it's not about the past. I mean, looking back in the past is great, but rather it's about the future, where we're heading. And one of the great joys that I have as an engineer and as a senior engineer is to work with the juniors and the younger engineers coming up and helping them and mentoring them. And it's a great joy to do that because I hope that I'm kind of helping them with their future. because it's not about what we have done. I'm more excited about what these young people are doing today and how they're developing into being some of the most greatest innovators that I've ever seen. I mean, they are coming up with things that we've only dreamed of. Or I'll tell you what, we only saw in science fiction movies. How about that? They're coming up with it. But it's not about the past, but rather the future. Secondly, it's what advancements are we going to see in the years ahead? We're going to see some great advancements. We're going to see some of the most advancements that we can imagine. Secondly, what tools are we going to use to get there? You're only as good as the tool that you use. And learning that tool, learning the power that's behind that tool, and knowing how to shift your gears. Knowing that you have that power in that tool and using it to its max. And most of all, who will develop these great new innovations? Who? I asked this question in Frankfurt a few weeks ago with an audience. And when I got to this question, I asked, who's going to develop these great innovations? A man in the back stood up and he said, me, I'll do it. That's the attitude. There you go. That's the attitude. That when the new innovations come, when the challenges hit us, the attitude is, bring it on. I can handle this. For some designers, they cower in the corner, they're in the fetal position, and they're worrying about what they're going to do about this. For other designers, they're standing up going, okay, bring it on. I'm good. Let's do this. Let's roll. Right? So you're going to see some huge advancements even in the next 10 years. Advancements in autonomous driving, IoT, exoskeletons is a big thing. Microcomputers. They're looking at having a computer that is one atom, based on atom development, based on atoms and molecules. Robotics, drones, nanotechnology. The one that's close to my heart is the Delft Hyperloop. This is a project that's being done by Elon Musk and a challenge that he puts out to universities around the world to develop a Hyperloop, a ground vehicle that will go 700,000 kilometers an hour, 700 miles per hour, 600 miles per hour. And they're doing it. And I had the privilege of working with the Delft Hyperloop, and I look forward to doing that in the future here as a technical mentor. And they are phenomenal. Phenomenal what they're breaking into in the new technologies. This is just a warm-up, guys. This is just what's headed our way. Now, you can either rise to the occasion or cower in fear. What's it going to be? What's it going to be? We're going to have to develop some techniques, and I can tell you that to be successful as a PCB designer, it's going to take three main areas for you to constantly keep concentrating on. It's going to take your tools, your techniques, and your training. It's going to take all three of those. And notice, I want you to notice something, that this is not a straight line. This is not a straight line, it's a circle, which means that there is no end. There is no beginning, there is no end to this. There is no beginning or end to your tools. There are no beginning or ends to your techniques. There is no beginning or end to your training, especially. A lot of people stop learning for some reason. They stop learning. They get into that comfort zone, and we're going to talk about that more later, but they get into that comfort zone, and there they sit, and they stop learning. Training is probably the most vital, important part of this. And as you can see, they feed on each other. They feed into the next. The tools feed into your techniques. Your techniques feed into your training. Your training feeds back into your tools. This is so important, this little diagram right here, to show you how you need to operate as a PCB designer to be successful. Altium has given us, the starting point here is Altium. Altium has given us some great, let me talk to you first off about about your training. Before I get into the tools and techniques and the specifics of how you do something, I want to talk to you about your training and how you're doing this. Altium has provided for us some phenomenal sources. If you go to Altium Live and log in, you'll see that there are some phenomenal sources available to you of support. There's the video libraries, there's design content, there's white papers that are available. And understand, Altium is constantly adding to these features, constantly adding to these items in here to constantly keep it fresh for us, which is great because we need nothing is worse than stale material, okay? Nothing is worse. All right, and fortunately, Altium has kept this fresh. They're keeping it fresh, they're renewing it, and they're constantly keeping it on that cutting edge of technology. So check this out. This is your first area of resource. Use your resources. If there's any message I want you to get from today, is use your resources available to you as a designer. This is a resource. This is something that you can tap into and learn and constantly keep learning. The other area is your training events. Altium has provided some of the most phenomenal training events available. They have the training courses, they've got the third-party events that they do. They have user group meetings, seminars, roadshow series, they have webinars that they do. And these are not just these are international in scope, guys. I have designers around the world, and what I'm able to do is I'm able to tap them in to a lot of these resources. So for example, 30 of our designers are in China. I make sure that they are connected up with the webinars that are presented in that area and get them plugged in so they're constantly learning new things. These are available to us also. So go to the website, check these things out, and get plugged into these, okay? As most of you know, we just finished our Altium Live events for 2019 here in San Diego and the other in Frankfurt. Phenomenal time. It was phenomenal. If you attended, you know what I'm talking about, right? Those of you who did not attend, shame on you, all right? Shame on you. You should have been there, because what has happened is this. It's very hard and difficult for me to explain somebody who did not participate in this what happens there, all right? It really is, because what occurs there is you come in a lot of times at a certain level and you are just drinking from the fire hose for 2 to 3 days, and you come out a different designer. You come out a better designer. And that's really what it was about. And so we are going to be doing another presentation or another Altium Live, of course, in 2020. And the only thing I would do is challenge you to be there. All right? I would challenge you to be there. Sign up, get signed up, and participate in this. This is a phenomenal time. And understand, I want you to understand something. This is not a 3-day commercial about Altium. These Altium Live events, it's not a 3-day commercial about Altium, or 2 to 3 days. This is about you as a designer and how we can help you, how you can be helped and improved, learning and different things like that. It's your chance to rub shoulders with other designers and start this whole thing, because really that's really what it's about. There's also third-party training opportunities I want to talk to you about. There is IPC. If you are not certified, if you're not a CID or CID plus certification through IPC, I would highly recommend this. This is something that's available for designers to participate in. This is not easy. This is very difficult, but I would encourage you to do that. You'll see here the schedule for next year, where those events are being held, the IPC certification throughout the nation, and the dates, and then also the advanced training and certification. Those are and where they're going to be held. Pick a day and go for it. We need certified designers. We need people who understand what we're doing, and the people who will take the next steps in learning, and that's what this is about. So there's also a third party I would highly recommend for you to get plugged into IConnect. Books, they've got a thing about flex cables, different flex designing, all these different things. So I would highly recommend you to check this out also. This is a great resource. I try to get most of our designers plugged into IConnect, and it's a big success there. I want to kind of open up the curtain here a little bit, and I want to talk to you a little bit about where I feel we're headed as a group. I mean, Altium has developed and is developing a community mentality. They have worked on this for some time as far as developing the community. And some time back, I actually ran into a story where 250 Amish men lifted and carried a barn with their bare hands. That's pretty amazing, all right? Basically, they picked up this barn and they walked it across the field, all right? And they dropped it down in another section, another area of the field. This is amazing, all right? 250 people came together and they did a project, all right? Anything is possible with a community, guys. That's my point on this. Anything is possible with a community. No matter what level you are at as a PCB designer, I would encourage you to keep moving forward and get tied into this community, because I can tell you what, if you are to advance, and hear me here, if you are to advance in your career, it must involve other people in some way. Let me repeat that. If you are to advance in your career, it must involve other people in some way. Now, some of you are going, well, no, I'm an island, I am a rock, I don't need anybody else. Well, yes, you do, okay? We are a community, and what we're developing here is a community. Altium is building the greatest community of PCB professionals in the world. And this event, as you're a part of today, is a proof of that. They are constantly putting out new presentations and new people and new resources and new training to connect the professionals with you to build this community. Also understand that they have resources online at the Altium Live site. They also have the forums. They've got the ideal page. They've got the wall that people can go there, talk about Altium. They've also got the bug crunch area. But then they also have the blogs and the blogging area. I would highly recommend you to check these areas out. Get yourself plugged into this community. Get yourself plugged in, because the job is made easier when you do it together. When we do it together, it's easier. If one person or even 10 people went out and tried to lift the barn and carry it across the field, it would have been a very, very impossible job for them. But when a big enough group gets together, what happens is your weaknesses are my strength. My strengths are your strengths are my weaknesses, maybe. And as we work together, we're polishing each other. We're helping each other. And that's really what this is about. It's about community. It's about helping you as a designer. So I would hope that you take the opportunity to participate in these training times, these sessions. Take these resources, plug into them, get involved. These are phenomenal resources. Years ago, maybe some of you would remember this, but years ago, I'm shifting over now to our tools and techniques. Years ago, there was a commercial, and it was for Prego spaghetti sauce. Now, all the Italians in the group are just horrified by eating spaghetti sauce out of a jar. All right, so there was a commercial years ago, and I think it was like the early 80s, where little mama there sitting there cooking the cooking dinner and making the spaghetti sauce over the stove with the big pot, big wooden spoon, just stirring it, you know. And the son comes in and he kind of looks at it and he goes, hey, hey, mama, hey, you took sauce from a jar? Yeah. Hey, but what about the garlic? And mama looks and goes, hey, it's in there. It's in there. Oh, what about the basil? I love the basil. And mama looks and goes, it's in there. Oh, mama, but what about the garlic? I love the garlic. It's in there. I can tell you that Altium's business philosophy is very simple. Their business philosophy is this: to provide the best tools to the PCB designers the best tools they can. That's their objective, is to constantly keep giving us the best tools possible. And I can tell you, after working with Altium for many years and using the tool, is that whatever you're needing to help you in your design, to help you in your area, it's in there. If you need simulations or SI, or you need signal integrity, it's in there. What about 3D modeling with your ECAD or your MCAD development? It's in there. Okay? But more importantly, what Altium has done is they've given us the tools to address specific challenges that we're facing. That's how they line this up. That's how they do this. Is they look at how that tool is going to help us with a challenge. And there are 4 challenges I want to take up today. And I want to look at specific tools that they have given to us to help us with those challenges. Now, understand, this is not inclusive in any way of all the challenges we face as designers. Of course not. All right? And these are not all the tools available to us. Of course not. All right? So we have the opportunity, basically, what we got here is we have the tool that's been given to us, the challenge that's facing us, and the tool that we have, and it's up to us to use it, to learn it and to use it. I was actually consulting with a company some time back where I was talking to one of the managers, and he goes, you know what? We don't use any of that fancy stuff in Altium. We don't use any of that stuff, the Draftsman, or that's just stupid stuff. That's what he called it, stupid stuff. And that told me that their group was going to be left behind in the dust, basically. Why? Because for us to face the challenges we're facing, we need better tools. And that's what Altium has given us. They keep giving us better tools. And look at this as a toolbox, guys. Look at Altium as a toolbox. You have a design process that you're going through, and at certain periods of time, at certain moments of time, you're pulling out tools from your toolbox and you're plugging them into your process. And we're only going to be looking at 4 of those tools that we've got available to us and how it directly helps us with our challenges. I can tell you the very first challenge that we face, and these are not particularly ordered in any way, but just our first challenge that I want to take up today is this: having a singular source for all truth for PCB designs. This is huge. And you say, well, isn't it common sense? No, it's not. It's not common sense. I've seen it where companies try to use multiple sources of truth, all right, multiple sources of information. Specifically, what we're going to be looking at is component information. When I first started at a company, I went in, and it was pretty amazing because what happened was I first was introduced to the engineer, and the engineer said, hey, come on over here, I want to show you something. I said, okay. He opens this drawer, a box, this drawer of his desk, and it was full of FR4, blank FR4. And he said, those are the boards we've done, but those are the ones we failed. Those are the ones that didn't make it through the process. I said, really? He goes, yeah. And at that time, we had like a 40% dropout of boards that were failing because of some problem that they had. And when I looked at the problem and looked back at the reasons, it was because of the components we were using, the source of information, the PCB data that we were operating from. And it turned out that we are actually at that company, we had 1,123 libraries. Let me say that again, 1,123 of them. All different sizes, all different shapes, sizes, colors, makeup. All right, none of them were managed, none of them were controlled, and probably none of them were correct. All right, but yet every designer that came into the PCB process had 1,123 libraries to choose from. How do you control something like that? You don't. All right, so our very first challenge that we had to that we're going to deal with today is this. The singular source of all truth for all PCB design, the solution, ConcordPro. That's your solution. Now, ConcordPro is the new kid on the block, we'll call them. All right? This is one of the newer tools that Altium has put out, and I can tell you it's one of the most exciting because this gives us a resource to do our designs with, our single source of information, our single source of truth. And we're going to look into this a little bit more. So what is ConcordPro? Well, according to a marketing statement they put out was this. It is the single source for component data, real-time sourcing information, component traceability within designs, and collaboration with your mechanical design team, all within the Altium Designer unified environment. Okay? So really, what does that all mean? It means this. ConcordPro deals a lot with component level, okay? So you have an up-to-date standardized component data that you're working from with a single shared library, a standardized method of defining components, visibility into component status. Altium Concord Pro provides one place to easily find, create, and reuse component data you trust, all within your design environment. This is your information. This is your one source of truth. And this is really good. When you got a component that you trust and you can actually, you know that it's correct, you can trust it and you don't have to lose sleep when you send out your fabrication to hopefully get fabricated and assembled. All right? Otherwise, if you don't have something like this, I'll tell you what, you're shooting in the dark with your designs. You're really possibly setting yourself up for failure because you're constantly possibly not getting doing it correctly because you're not working from a single source of truth. The other area is a bidirectional ECAD MCAD collaboration. This is really great because now through ConcordPro you're able to push and pull MCAD information back and forth between them. And we're going to talk more about that here in a little bit, but this is a really great area to work. Also, you have component traceability, where used, because when you have a situation, let's say the procurement people come over to you and they say, oh, by the way, this component is going obsolete. Wow, okay. So I'm working on a board that's using that component, for example. But wouldn't it be nice to know where every board that component is used? Well, that's the good part about ConcordPro is that it uses that information of where used, and you can trace that component throughout your whole organization. The last area is a real-time sourcing information for those components, and we're going to actually look at that challenge as a separate thing here. So Altium ConcordPro brings live supplier data directly into the design environment so you can design with real-time information including availability, alternatives, and pricing at your fingertips, okay? So this is all the marketing side of it, okay? But I can tell you that for us, we had the great opportunity to use, to use this, and I can tell you that it is a phenomenal resource for us. It's our go-to resource now for our components. But although components is the main focus of this, it's not all of it. You will say, well, you know, I have a pretty good library. And you'll say, well, you know, what else can ConcordPro do for me? Well, ConcordPro, although it focuses on components, it's also some other several items. And let me kind of go through the short list for you on this. Give me a second here. So ConcordPro covers PCB project design, PCB assembly data, PCB fabrication data, binary files, 3D models. It covers simulation models, managed schematics, layer stacks, schematic templates. It covers BOM templates, output job files, scripts, designer preferences, catalogs, project catalogs, draftsman templates, component templates, and project templates. Too early in the morning to try to do something like that. Don't get into the mindset that this is all just about components. This is your go-to resource for anything in your designs. Your projects, your files, your resources. My goodness, what we did with our area, with our setup, was we actually set up a resource library section in our Concord Pro, where we actually have resources for people to go and read, PDFs, articles, different things like that. And it's become another great resource for our designers to have that available to them. So, but wait, one moment, there's more, okay? There's also an ECAD to MCAD collaboration with Concord. And then also, not to be left out, you have your Concord to PLM connection, which goes to Arena, Agile, and Windchill. Now, this is, I hope you see this, that this is a pretty good, strong tool for us to use. It is what's going to help us, not just with what's internal to our PCB design, but what's external. What are some of those external things now? Our ECAD to MCAD collaboration and our connection then over to the PLM. This is huge. This is a great area. So all these, I want you to understand, all these things are done through revision control. Each of the items has a revision. So just kind of give you a heads up though on something. Little comment down here. It's best to set up first thing at the beginning of your library. It's best to set up your management plan at the very beginning of your library. Because once you start developing this and your library starts growing, it gets very difficult to shift gears and to change your management plan. So what I would highly recommend for you to do is at the very beginning, sit down, understand what's going to go into your library, into Concord Pro, know what those revision schemes are going to be. Because not everything is going to have the same revision management plan. For example, our components for us, we have a simple numeric revisioning plan, meaning that every time you go in, each time you change your revision and it goes 1, 2, 3, 4. All right? But for our projects, we may not want that same revisioning plan or that revisioning scheme. What we may want to do is we may want to shift that over to what I show here of a major or minor. Then you're working with a numeric and alpha. Now you have a lot more flexibility on what you can revision and how you revision it. So basically sit down, understand what your revision control is going to be, understand how you're going to do that. And this is all done through Concord Pro. This has nothing to do with the third-party software in any way. So also what you can do there in the revisions is you actually can have content types for each of those contents that I went through. Each of those can have a revision. So you can actually say for this content type, I want this revision cycle or this revision management plan to be effective. So you can actually have a lot more flexibility. So every time that you open up, then let's say you start a footprint or a new symbol, well, it automatically pulls in that management plan. It doesn't have to be set up every time, which is good. So the other side of your management plan is going to be your life cycle, your schemes. Every component, guys, is going to go through a life cycle. It's going to go through introduction, and it's going to have its prime, it's going to decline, end of life, and be discontinued, and then it's going to be off the market. Every single component will go through this. So don't feel as if this is something you can skip over, because every component will go through this cycle in some way. They may have different names here for the stages, but each of these will go through a life, beginning of life, mid of life, and end of life, okay? So just keep that in mind. And what Altium, what ConcordPro allows you to do is easily set this up. It easily allows you to put in the blocks that you need to do in a flow such as this, and easily be able to drop it in and just connect the modules, or connect up those blocks. So keep this in mind, and that's the great part about ConcordPro. That was a question that I was asked before, is this hard to set up? I go, no, it's not. A lot of this is already set up for you. You just pull it out of the box, plug it in, and start using it. And then you can massage it, you can change it to however you need for your system. So that is ConcordPro. Before I go into the second challenge that we face as designers, this is very, very closely connected to ConcordPro and a part of ConcordPro. This is the challenge of a component availability and sourcing. This is a huge area, and a lot of time that I spend in my job is spent on component availability and sourcing. A lot of times, by the time we get through a development of a product, we've actually already seen that components on that design has changed life cycle. They're now reaching the end of life. They're reaching their end of life, or they're deprecating, or they're not recommended for new designs, or they're obsolete, okay? This is probably one of the hardest, difficult things to handle. I know it's something that's affecting us. I'm sure it's affecting you. And what we needed a tool to help us with this. And the solution for that is ActiveBOM. All right? And this is the tool that's available to us to help with our part availability issue. And I actually, I was kind of amazed. I was at Altium Live a couple weeks ago, and the question was asked, how many of you use ActiveBOM? How many of you use it? And I would say not even half of the people raised their hands. And I was amazed by that. I was really amazed by it. I'm not sure why, but I know that if you're not using this, that you're still struggling with the challenges that we have with this. You're still having the issue of component availability and sourcing. That is still a challenge for you. You see, you can have all the power in the world. You can have all the features in the world. You can have all the best tools in the world. But if you don't shift it out of first gear, you don't go anywhere. If you don't shift it out of first gear, and that was really what I'm seeing in designers, is that they have the tools, they have the power behind them, and they don't shift it out of that first gear. So ActiveBOM, it's one of our go-to tools that we've now continually keep using. We are in the midst of a lot of component shortages still. I mean, I think it was over a year now ago that I talked about this same issue, about component shortages. And we are still seeing a lot of component shortages issues that are happening. I think what's occurring is that a lot of the component manufacturers now have kind of shut down entire product lines, and they've kind of shifted over to the more popular products. They've shifted over to the more popular components. So what has happened there, you've seen a pretty high increase in the components that are now reaching the end of life, deprecating, going obsolete very quickly. I mean, we've seen stages like this before. So I mean, it used to be that all the components on the board were axial through-hole components, okay? You would lay them on the board and you'd have the big through holes and all this and that, and they're still around, but they're not used in designs very much. So now what you're seeing is you're now seeing a lot of the surface mount components, especially in the discretes that are the larger sizes, that are now going end of life and deprecating. Because the choices that people are making are to go smaller and to go to the less power or to the smaller packages. So now what's happening is the larger packages are not selling as well. So a lot of these part manufacturers, what they're doing is they're just deprecating, closing those lines entirely, switching them over to the more popular sizes, and they're just putting more of those out. This is a part of this whole thing about part availability. There is the component lead times are massive. What I would challenge you with is this. Go into DigiKey, Octopart especially. Look at those lead times. I mean, you're looking at lead times up to 6, 8, 9, 10 weeks. All right, 26 weeks for some of the longer ones. You're looking at times that on just components that are just unbelievable. And you can't design that way. You can't. You cannot design with a component that may be here 20 weeks from now. You can't do it. You cannot develop a product in that, because I'll tell you, I'm sure the conversations you're having are the same conversations I'm having. And those conversations are coming from my manager and my VPs, and they're asking me the same question. John, when can we have this? When can we get this? When will this product be done? Right? Because why? They're concerned about getting that product to market. That is their concern. They want to get that product to market. And that doesn't happen until you're done with your job, until you actually have something to put onto the shelf and for someone to buy. You know, one thing I tell our designers is this. I say, look, you're not here, you don't get paid to design. This company does not exist to have you design things. This company exists to sell stuff and to sell products. All right? So we don't benefit from any of this until we create a product, we get it on the shelf, and the customer comes along and buys that product. Then the whole cycle is complete. But until then, it's up to us to make sure that we're keeping our time to market down as low as possible. I'll get off my soapbox on that one for now, okay? But one of the major problems we're having is the component shortage issues. Now, what's happened is a lot of these components now, it started with the MLCCs. Now it's gone over to the other issues also, the other component types that we're actually seeing now. Some of our mount temperature sensors, our board switch ICs, MOSFETs, our suppressor diodes, operational amps, even our thick and thin film resistors are out there a ways. All right? So you would think, come on, this is potato chip stuff. This is resistors, for goodness sake. Nope, they're getting hit too. So this is a major problem. This is absolutely a major problem. And I don't see this slowing down for us at all in any time soon, guys. I really don't. I don't see this changing for us. The expected growth in the electronic industry is, you can see that in the 2018, it was 4%. 2019, we've seen a growth of 6% in our industry. They're expecting growth in 2020 of 8%, and 2021 of 5% growth. this is great news for us. This is great. We're going to be employed for many, many years, it looks like, okay? Because of this constant growth, this demand for electronics, this demand for the latest and greatest. And you think, well, you know, could it ever die off? Well, maybe. It could possibly, you know, but I don't think so. All right, just look at any of the major electronic systems that we put out, new phones or different things like that. Look at the line that is out there days beforehand for the release. All right, this is huge, and I think there's still going to be a demand for this. The real question I have to ask myself is there enough coffee to handle such a major undertaking as this? Is there enough coffee? I mean, that's the real question. So, but this whole problem about part shortages is not going to go away anytime soon. So what is driving this crisis? So what is driving these numbers? The three main industries that are doing this. The IoT industry is number one. It's expected to have 20 billion new IoT devices in homes in the next 2 to 3 years. 20 billion. All right, think about that. 20 billion new items. All new products, all new things that people are putting in. Now, I will say that I work in a company of the grand, that this is our arena that we work in, Internet of Things. Everything being connected to the cloud in some way. And it's a huge area. I can tell you that I just bought a refrigerator and it's connected to my phone. I have a refrigerator that connects my phone and gives me text messages from my refrigerator to tell me that I'm out of milk, okay? How cool is that, all right? All right? But my concern is this, is that if we go too far with this, all right? So for example, what happens when my smart refrigerator starts talking to my smart scale, okay? And they start talking and chatting a little bit. And it turns out that when I go to my refrigerator and I say, okay, refrigerator, put a dozen donuts on my shopping list, the refrigerator's going to reply back, I'm sorry, Dave, but I can't do that. I've been talking to the scale and we decided to put you on a diet. I mean, so I mean, I'm afraid that may occur sometime, but at some point, it would be like a scene from 2001 Space Odyssey, huh? When the computer sort of takes over and says, I'm sorry, Dave, but I can't do that, you know? So Internet of Things is something that's really driving this whole thing. Also, the mobile phone industry, it's expected to have 1.5 billion new phones built in the next year, 1.5 billion. Each one of those uses 1,000 capacitors. So figure out the math. There's an average of 3 trillion capacitors that are made each year, MLCCs. There's 3 trillion. And I can tell you, so if you do that math, 1,000 capacitors in 1.5 billion piece, you're looking at half of the supply automatically going to mobile cell phones. All right. The other area is the autonomous vehicle driving area. Autonomous driving in vehicles is a major undertaking a lot of companies are taking up, but it's also sapping a lot of our supplies, a lot of our parts. This is a huge area. A gas engine uses about 3,000 to 4,000 capacitors. A fully autonomous vehicle uses about 22 to 25,000 capacitors. So now you're seeing just a huge demand in all 3 of these areas, sapping out the supply that's available. So this is why we're seeing this. And this is what's driving this, is that a lot of these industries' demands are really pushing this out. Now, in addition to that, is what's happening is that a lot of these companies that are now finding out, oh, well, we're going to have part shortages, let's go ahead and double up our order. Let's triple our order. So now you have people who are stockpiling components, all right, for the quote, rainy day, right? So they're now stockpiling the components. I can imagine some guy sitting in his basement, surrounded by MLCC capacitors going, they're mine, they're all mine, you know? And they're hoarding these components. So keep that in mind also. That's another issue. Just something I came across here. Speaking of the automobile sector, a Wisconsin couple were treated for minor injuries at the local hospital emergency room after their smart car hit a squirrel on Highway 8. The squirrel refused treatment and had left the scene. Okay, so just that news flash just came in there. Figure I'd give that as a public notice. It's not what this what this all means for us is simple. It's not going to be business as usual. And I tell you, one option for you is going to be this. You can simply bury your head in the sand and just say everything's going to be just fine. That is an option for you. All right? It's not a very good option, but it is an option. Okay? So let's talk about active BOM and how this helps us and how we can use this tool to fight this challenge. So if you go up into a file and you go into new, and you go in with your schematic open, you have active BOM document. Now keep in mind, you can only have one active BOM document that you've created. So if you already created this and you go back up through here, that will be grayed out since you've already done this. So you can only have one active BOM document in each project. So this is the sort of report that comes up, and it will then, what it does is it goes out, looks at suppliers and vendors, and determines your sources of information. Now, a big question that a lot of people have, and I found this to be true from Altium Live events, was that a lot of people were interested in where this information comes from. All right, I think number one source for it is Octopart. They have a lot of vendors. There's actually 13.8 million components on Octopart. Believe it or not, 13.8 million. A lot of those are tied in here. One of the big questions I got was, why is it that if you look at, for example, in this list here, you'll see that C3 is not recommended for new designs. But if you go there, if you go to, let's say, DigiKey, they seem to have a lot of stock. They seem to have a lot of supply. But yet it's being flagged as not recommended for new designs. I found that I did see that what Altium is now doing is they actually are tying an algorithm into more of the sourcing information from futures, component futures, and different things like that. It's ability to take a snap to look at where they're at now, but then also what the industry is going to be looking at for 6 months from now. I've actually seen the situation where we fell into that trap where we went to DigiKey and we said, oh, okay, yeah, it looks like they have plenty of stock. Let's ignore that, not recommended for new designs. And it hit us every single time. It bit us in the rear end because it would be maybe 4, 5, 6 months, maybe even 8 or 9 months down the road, but it would ultimately hit. It would ultimately hit us that component would then be end of life and then also would then be obsolete. Somehow, all right? And I personally believe that Altium sees into the future. That's my conclusion, okay? Okay, I'm joking, all right? But they do have a very good system of being able to record and to identify these markers that they've got available to determine that this component is reaching end of life and it's not recommended for new designs. And somehow they get that information out to us. And so we have now decided to follow those recommendations. So a lot of times with those recommendations also comes replacement that you can put a then substitute component in. So what happens is your main work area is up here. Up on this main bar up here, you have different views that you can have of your BOM. You can have your flat view, the base view, or the consolidated view. You can also then have it grouped by different items. You can have a line, all these different areas. So one of the ways that we use this is that, for example, if we have a supplier that we have a BOM and we have a supplier, so what we'll do is we'll actually group it by the supplier. So then when we place our order, we can actually then go out to that single supplier, have the entire list of components that we are ordering from them, and it's all grouped together. It's very, very convenient. Also, you can add new items, which is your managed components or custom items. These are items that you may not have on a schematic or any components or something like that. Also, then you have some line options there of hitting your how your lines on your BOM are numbered. So, I mean, there's you can either do it by single numbers or by tens or hundreds or whichever way you would want. So, let's look at a component here, for example. So, in this line item here, the C10, C11, etc., we have, for example, our manufacturer parts. This is a capacitor. This is a 0.1 microfarad capacitor. You have your manufacturers for that component, and then in that manufacturing area, you have a lot of great information. So you have here a manufacturing life cycle, which says the volume is production volume. You have the available stock. You have a data sheet. You have then the SPN supplier part numbers. These are telling you that there's 14 suppliers for that part, which is great. And then you have a ranking system for that manufacturer. So you can actually give them 5 stars or 4 stars and give out your primary, your secondary, and so on of your manufacturers and manufacturers of your first choice, second choice, and so on. So in that then also then is your supplier information. All right? From that manufacturer, you may have those 14 suppliers, for example, of who supplies that component. Also, you can rank those as your first choice. So you can say, I want this, I want this supplier or that supplier, and so on, to be able to organize your components pretty easily. So under your properties windows, I want to kind of go through this very quickly, is that you can actually have a general area where you can set up a production quantity. The way that we use this is we actually, excuse me, we actually have in there an estimated quantity of products that we're going to be selling for the year. So what we're looking at is we're looking for the baseline budget of how much our components are going to cost us per unit, or cost per unit. So we want to make sure that we're under our budget and making sure that we're under our cost, our pricing for that board. So you can actually set here your production quantity, and then also your price per board, and then what your target is, and it will then flag items that are out of target for you. This is great, because this then helps us with our pricing also then on our boards. Also, you can set up your supply chain of how many suppliers, solutions you want for each, what your favorites are, who's your favorite supplier. You then have your BOM sets that you're able to put in there. These are sort of the BOM templates. You can also then have the BOM items, designator groupings, different things like that. And then lastly, you have your BOM checks that you're able to do. And this will then tell you what your flags are on your different components. As you can see, this list here, there's like no suppliers, no solutions. There's different items that you'll come through here. So you have 6 items that are NRF-ND, which stands for not recommended for new designs. So you have 6 components that fall into that category. And then you had no NPM ranked, so no manufacturer part number ranked. So that's going to be the big one I found. So if you see there, you don't have what those stars selected. That's what the problem is there. So easily what you're able to do then is you'll filter out those issues and those problems. A lot of times you can change vendors, change suppliers, different things like that. So this is your go-to resource for changing in, polishing your BOM, okay? But then you're going to have this list that basically something like this, where it comes up where it says, you know, this is not recommended for new designs. This is not this component. And you may hit the situation where you don't have other suppliers. You may hit an MCU, for example, or something like that, where you actually have to pull that off the board. Now, my question for you is this. Would you prefer to know that information before you go into fabrication or after? Just wondering, you know? Because I can tell you, after it goes into fabrication, goes into the assembly house, and they start giving you the phone calls back to you saying, oh, by the way, that component's no longer available. Or even worse is that you get through assembly, you get it out to a production, or you get it out into production, and then it hits you that this component's no longer available. Now what are you doing? Now you're back to development. Now you're back to taking that unit that you just put on the market, put into your customer's hands, and you're pulling it back and you're saying, well, okay, well, we need to do some more further work on it. How embarrassing is that? Really? I mean, how embarrassing. I mean, you're not just talking about lost money now. You're talking about lost market share because the image that you have in front of your customers, that is irreplaceable. The image that you give to your customers is just hugely valuable. And when you lose that trust, it's very difficult to get it back. So let me go through the third challenge with you very quickly. That is ever-increasing HDI demands on designers. Our designs are getting smaller, they're getting faster, they are getting hotter, okay? They are getting, the complete designs are totally revolutionizing how we design. And HDI, high-density designs are huge. And you're going to hear more from the other Team Up and Train people about this HDI area. But we have a very good tool to use, and that tool for us is the layer stack-up tool that Altium's provided. So there's 4 factors that you need to consider with PCB designs, okay? Number 1 is the 4 factors are the number of layers, the number and types of planes, power and or ground, the ordering or sequence of those layers, and then the spacing between those layers. Let me repeat that. The 4 factors with board stack-up considerations are this: the number of layers, the number and type of planes, power and or ground, the ordering or sequence of those layers, and the spacing between them, those layers. That's the 4 considerations that you must take up. All right? And I would highly recommend for you to tie into some of the great material that's available by Happy Holden, the Lee Ritchie, and all these people who have spoken about the stack up and how important that stack up is. Very, very important, and I'm not going to get into it very deep here. But so the layer stack up is now a controlled document. This is where you can actually set up your layer stack up for your project, and all you do is you go down to design, layer stack up, and this is what comes up. So let me kind of go through this here for you. Basically here on this side in these columns here is that you have the number and the name of your stack, all right, what layer that is. Now, what I would highly recommend is give it a descriptive name. Don't just say layer. Give it a descriptive name, something that will identify you as how you're using that. Then next in is a kind of a newer area for Altium. I think this came out in Altium 18 or 19. I think it was 19. Was the selection of materials that you can now select the type of materials that you're putting into your design. Now, this is really important here because you're going to see here in a bit how they use this information a little bit in other areas in the rest of your tool here, okay? Because this is kind of a building block that they've used to help you and help you develop, okay? So here you're actually able to select out materials, different things like that. and you actually can select a type of material. Now this becomes really important when you get into the higher frequencies and different things like that, is to control the material types you're using. So keep that in mind. So here you can also then select, it automatically brings in all the information, your thicknesses, your DK and DF. Now the other side of your layout, or your stack manager, is your via area. This is also something that's been greatly improved on, is the ability to lay in vias. For example, this here is a through-hole via for your board. And as you can see off to the right there, it's a top layer down to your bottom layer. But if you wanted, you can simply add a new via, and it's that simple. Okay? You push a button. That's how much simpler could it be, right? So, and in that, then you can also identify the layers that you want to go between. This is going between 1 and 2. And then also what type of via it is, whether it's a through hole or a micro via. And then whether it's mirrored or not, you can then also select other buried vias. It's that simple. You just keep adding them on there. It's very, very efficient. So let me kind of give you a standard stack up for a design. A lot of people, when they look and they go, well, what's been the biggest board you've ever done? Well, I've done up to an 18 layer. I know people have done more than that, okay? But the rules are the same on your stack up. And those rules are this, is that you have identified your layers, as you can see in that chart down there, is that you have a layer, and you have a, like in the four layer board here that I've got 2 signals, a ground and a power. Those 2 signal layers are paired. So those 2 layers, whenever you're working with that, you go from that layer to the other layer. So what you're doing is you maintain that pairing between that layer, and then if you notice, you have an H and a V. What those H's and V means is that the routing will go horizontal or vertical. So when you're on layer 1, for example, the routing will primarily go in the horizontal area, and when you drop down a via to the other layer, to the other signal layer, it will go in the other direction of the vertical. Now, with that sort of structure, sort of that standard that you're going to now set up, that rule that you're going to set up with your layers, you can now basically set up any number of layers. So for example, here would be your layer stack for a 6th layer. Now understand, these are not all, this is how it has to be done. Okay, you can do that, do it another way, but I mean, try to keep this structure though. So you see here that you have a layer pair between layer 1 and 6, and you have a layer pair between 3 and 4. And you also see here that the high frequency signals are then in the center or in the middle. There's a lot of discussion about this, okay? If you listen to, please listen to some of the new designers. I'm actually shocked after listening to Richie and Hartley and these guys, how any of my boards work, okay? I am actually absolutely shocked that any of them worked. Because they kind of blow the standard out of the water about this. So please read up on this. They're leaders in this industry. But notice that you have your top, your 1st and 6th layer, and then you have the then the V2 and V. You have that set up there. So here's, for example, a 10 layer, 12 layer, so on and so on. So also another major part of your tool manager and your layer stack manager is your differential pairs. Down here you have your impedance, and really what you do here is you can actually add in your impedance profile, and what happens here is that it automatically then calculates out what your impedances are going to be for each of those layers. So as you can see, as you say plus, what it did was it basically brought in the material that you selected, And a major part of the calculations that they do for the differential pairs is based on that material type, okay? Because if anyone has heard Eric Bogatin, it's all about the space. It's about the energy in the FR4, okay? So if you click on any one of these calculations there, it will actually then identify the differential pair stack relationships of what is being referenced to what. So each of those, you can see that. So usually what we try to do is give it a good description, give it a type, whether it's a single or differential, what your target impedance is, and then a tolerance. So also then you have your transmission line calculations there of how they came about this. All these different things. Now, one of the things is that if you look here at the function, you can actually adjust that number. You can use the calculated value for your trace width, or you can put in your own trace width. But notice how the calculated impedance changed. So right now, if you took that trace width up to 6 mils, your calculated impedance for this line here, this 100, you're shooting for 100 impedance. It's now 91%. So your deviation of 8.295. So you're hitting that window a little tighter. Now, if you went up to 8, for example, now you're at 82, and it will come up with a warning that will tell you you're out of tolerance, and that will come up as a red flag. It won't let you move forward from there. So basically, if you save this, it will then push it into your PCB. Now, what's important is that you place these in as your items in your schematic, okay? So understand that you've got your differential pairs, and you want to make sure you get those rules into your schematic. So all you simply do is, here we have an example of a differential pair setup with a blanket around it with a differential pair rule set. And all you do is simply say add, go to differential pair routing. And under there you see the load PCBS stack and calculate track with values for. You can actually select right there the rule that you just set up in your impedance calculator. So automatically you see here the rules are dropped in, and you don't have to do anything about that. So you simply set up in your schematic. Now what has happened is your design rules are automatically brought in from the impedance calculator, and your design rules are embedded in your schematic. This is where they belong, all right? So then you would push those into your PCB, and you have your rules set up. Make sure then you can also set up your differential pairs here to show that to use a certain impedance profile. So that's really great. So the design rules are automatically brought in from your impedance profile. Now, a little additional thing here is about active route. Now that you've got your design rules set up, you can now use those design rules to push your routing. All right, those are just fed directly over into your routing. See how this is all connected? You have your differential pair. You have a material, a stack up that you choose. You have a material that you choose. From that material, then it chooses for you your impedance calculations for that type of material. You push those impedance rules into your schematic, into your PCB, and then that's what drives then your active routing. Simple. You don't have to set this all up. It just automatically is all connected. It's like they planned it this way, huh? So, so here you have, for example, when you begin to route this trace, and you route this differential pair in, it's all based on the guidelines of the design rules. So here we laid this trace in, and as you can see, it came in at 4.587, which was what we originally set up in our design profile. So you can also have active route, which a tracing is automatically laid in according to that. Active route is an additional tool that I didn't have time to go into today. Definitely check this out. It is a great tool to use. Then you have here your differential pairs. You can also use a route guide to guide them, and they will follow then that route guide. So if you want to select a certain number of routes and have them guided in a certain direction, you can do that. You can also then set up match length pairs by going into your rule set and setting that up. And once you go in here and you say, give me a match length, and you hit active route, the traces are routed according to multiple rules now. You're looking at the differential rules and you're looking at the length tuning. So this is great. This is all done automatically within buttons. See, you're just switching it in buttons here. Now, it's important to then also make sure those impedance profiles rules are placed into your design, okay? Those that simply by going to place and transmission line table, all that information from your impedance calculator was now placed into your schematic, or into your fab drawing, I'm sorry. So my fourth challenge is this, system designing. It's becoming more and more prominent that we're not working on single PCBs anymore. We're working multiple PCBs. PCBs, flex cables, harnesses, connections, all these different things. The solution for us in all this is your multi-board designing, your multi-board tool. So designs are requiring more multiple boards and PCB stack-ups. There's a lot of challenges when we're dealing with this, because we have the nets that are assigned correctly. We want to make sure nets are assigned correctly. Are the connectors orientated correctly? The plug-in boards fit together? And are the connected boards fit into the enclosure? So this is where you're starting to develop off that single board mentality and saying, okay, how will my entire system work for me? So a mistake at this point of the design means a lot of wasted time and money for you that if you mess it up, okay? So now you may have to go back to the single board level to fix some issues, okay? So looking at this, it's structured a lot as the same way as our schematic and our PCB, if you remember. So here you have a multi-board schematic and a multi-board assembly. So you can actually set it up in the same way. It's actually simpler. I find it simpler because you're now working with blocks, not just components. Each of these blocks or modules are considered as a component and the interconnect. So just real quick, this is the process for setting up your essential steps, your overview steps that you want to go through. Create an Altium design multi-board project. You add a multi-board schematic document. You add the block, the modules. Each module then appropriates to a child project. Then you import that child project connectivity, and then you add connections between the modules to create the logical system design. So really what you're doing is you're dropping the blocks, you have your connectors identified, and then you're connecting those up, and then you're pushing each of those modules into the multi-board design. So let's look at starting a new multi-board design here. So if you go into File and New Project, you can actually look and say at the project name of a multi-board. So you have here then, you can create, and then that gives you your placeholder for your project. Here is where you would drop in then your multi-board schematic and your multi-board assembly, and you're ready to rock and roll, really. So here you have your multi-board schematic. You'll see that all you really do is you drop in modules here. So, but before you do that, you want to understand how your project is structured. For example, you have interconnects between connectors and let's say your modules here. So here we have a DDR4 SODIMM that is going to have a memory board plugged into it. And what you need to do is identify those connectors as interconnect connectors, that they are going off board and connected to another board in your system. So the way that you do that is you have system here. You have a parameter in that schematic symbol that says system and connector. So it's done through a system parameter, and it says system equals connector, and that's your result there. Your value is what the word I'm looking for. So each of these connectors, for example, there's 3 connectors on this. You have your main board, and we're going to do a simple project here of that you have a main board and 3 piggyback boards or 3 plug-in boards. So for us, J8, J13, and J20 are going to be our system connectors, which means they're going to have modules that are going to be plugged into them. So fortunately, all you need to do here is you place a module and you give it a unique designator of some kind. We usually say mod 1 or an M number and then a title of what that module is. So this helps you kind of structure your assembly drawing much better, or your assembly schematic. I'm going to use the right terms here. Makes it much better for you. So then you simply identify the source that's going to be connected to that module or that block, and that is now connected. So that's your main PCB there. So then you can import your child. So then, as you remembered, what we did was we identified three of our connectors as being interconnectors, and those were J8, J13, and J20. So now, as you import the child, you automatically bring in those connectors, and you'll see that those have already been dropped in. So it's all done through your schematic and done through that, and identifying those parameters as system parameters. So here then you can actually set up, we're going to lay the other 3 modules down, and then you'll see that you can actually see each of the pins that are available there and what their net names are. So we're now going to look at all you have to do from here is make the connections between. So here you can actually do a direct connect from one J20 up to X1, for example, and so on. You can actually also then have cable and harnesses that are available to you. So I want you to understand the power that you're driving here. All right? This is not a broken down 65, this is not a broken down VW Bug that we're driving. What is it? It's a 2020 Corvette. And that's what we're driving here. And we have the power behind it. So a lot of you can actually verify then these connections that you've got here through the connection manager. And understand, if you have different names on different nets, as you see here is from and to, you can actually change those names and push those back to your design. So you can update the child projects, or you can, it goes both directions, okay? So let's say we swap lines then on 2 of these connectors, and you run your connector manager again. What you would see is you would actually see a crossover here of nets that have now crossed over. The reason is you changed them on one board, but you did not change them on the other board. So now the interconnect between them is now crossed over. And this will actually flag those as a bad connection. So this is where the real benefit of working on a system level, you may have a very good board on a board level, but when you get into the system level, you begin to see all these interconnections between the connectors and the lines and different things like that. That's when you can have a change on one board that affects everything else. So keep that in mind. So you can actually then fix it on this level and change that. Now, so here you also have ERC rules that you can set up for your multi-board schematic. Pretty simple stuff there. Any errors, they'll appear in the message panel for you. Now you're done with your multi-board schematic. You can push it into the PCB, and as you can see, or the multi-board stack up, or the board, you can see here that we're pushing 4 modules in here. We're going to be pushing module 1, 2, 3, and 4 over into the module, and this is what comes up, is you have your main board and then the 3 modules below there. It's very simple, huh? Very simple process. So here you have that structure again. And let's just kind of learn how to navigate in this assembly a little bit. Because I can tell you that learning how to navigate in your PCB is really important. So keep in mind that you actually have a gizmo that you have available, that you can churn the board in any of the planes or axes that's there. And learning how to hit those planes will actually navigate the board back to where it was. So learn how to navigate your board pretty easily. So also there's a gizmo, axis gizmo on each of the modules. You'll see that here on the corners, and you can actually rotate that module. And any of the, there's a slight stickiness in the motion whenever you cross a workspace plane. It will stick a little bit, so that means that you know that you're right on it. So keep that in mind also. So talk about mating. Now we're ready to take our module and plug it into our connector here. This takes a little bit of practice, so get used to it, practice it, and I can tell you that once you've done this, it's really great. It's very easy. But mating, you want to, first item that you're going to select is the one that's not moving. All right? The first item you select is the one that does not move. The second module then is you select a common point and you simply snap it to that. So like for example, I'm going to select this midpoint of my tab. I come over to that surface does not move. I come over to my module, I push the midpoint of that tab, and automatically it's brought over. It's that simple, guys, but it does take some practice, okay? So also in your panels and your multi-board assembly, you have your mating there. The new mate is added to the panel. This is where you can actually go in and fine-tune it and adjust it if you need to. So keep that in mind. You can check it out, and they give you there the helps on how to move that module a little bit, okay, if you need to. So can use your up and down to move the module on the active plane. You use your control to move the axes, okay? So there you have a completed multi-board design. Now this is great, but I don't know of too many boards like this where they're sitting out in midair. So you're actually able also then to insert PCB parts, MBA parts, step parts. So for example, we want to take this now assembly and we want to put it onto a back plane or a back panel. Same rules apply. I mean, you can easily go ahead and select the center of that hole, and automatically it just lines up. So you select remember the first item you select is the one that will not move. The other item is the one that will move to it, all right? That's very, very easy. Sometimes also you'll see that this will be rotated. Let's say the back panel will be rotated maybe 90 degrees. That's where you would go into the mate and you would actually just go ahead and rotate it then. Use the fine mating tools to adjust that or rotate it in where you want it. So it's really very efficient, very, very efficient to use this. So above that, though, you now have the ability to check for some collisions. So it used to be where you would take the 3D step model, for example, you would export it, send it over to your ECAD person or MCAD person. They would then put it into SolidWorks or another program, and they would then ultimately sit there and wait for it to load up, all that, position it, and all. It was a nightmare, really. But what you're able to do here is you're actually able to check for collisions yourself. If you go to Tools and check for collisions, you can actually then it will highlight all the places that are colliding, and then it will also put those messages in your message window. So here, for example, you see here where this board is impacting the standoff a little bit, and you have that red area. This is something then, because of another tool that we talked about was what? ConcordPro. Well, because of the ECAD MCAD collaboration, you could automatically push this over to your, you could actually take all this information and push it over to your MCAD person, and he would say, oh, okay, let me trim either that post or move that post or different things like that. He would then automatically push it back to you. You would pull it into your design. You'll see his changes. There is no 3D step models. There's none of that. There's now a single unit of work that's being done by the worker, by the MCAD and ECAD. There's now a connected line there between them. And the line that connects them, by the way, guys, is ConcordPro. So that's the software that allows this all to happen. So this is I hope what you're seeing here is all these tools kind of interact with each other. They kind of act and they're connected to one another in some way, so which is really great. So you could also do a section plane view. If you go into toggle plane view or shift control E, you can actually then cut into the board. And this is great because you want to be able to see maybe some other details of the board, anything like that. You can also then toggle it off. So understand if you make any, this is a view here of the multi-board assembly and the master board. Let's say you want to make some changes on the, once you get it into the system level, that you want to make some changes. Well, let's say you want to go ahead and move this capacitor over. So you can actually select an individual component on your multi-board design and move it. And what would happen is this, is that it would go ahead and push it back over to the master, and you can execute those changes, and you'll see here that it also was then updated on the master board. Now, I need to check whether the auto route feature of reconnecting components would work here, but I need to find out. But the worst case scenario is that you would need to go ahead and reroute that connect or that component there. So keep that in mind. So one of the big features of Altium 20 is going to be where we're actually able to create assembly BOM levels now through the entire system level BOMs, we'll call them. So this will include all the components in all the boards, all the parts available. You'll be able to set those up with all the features of active BOM. So once again, we have an overlap here of features involved here. So keep that in mind, okay? Understand your tools. Active BOM is probably one of the, also you'll be able to push these now into your assembly drawings and different things like that. Once again, Altium is constantly improving on the tools, improving on the things that are available to us. That's the key here. And this will be improved on. All right? Really take notice of this note I put down here. Watch for additional features in upcoming releases. This is the philosophy of Altium. This is the way it works, is that they will constantly keep improving on it. Keep bettering the tools, giving us the ability to do our jobs better. You know, a lot of these save a lot of time. These tools save a lot of time. Being able to route 10 traces at the same time through active route, or even more, is phenomenal, okay? A lot of these tools save a tremendous amount of time. And I keep trying to tell Altium, I said, you know, some of us do work out here by the hour. Some of us do, all right? And you're making our job so easy now that we have to come up with new excuses of why something took so long, all right? Well, you know, it was really hard pushing that button. You know, it took me a long time. I had to decide whether to do it or not, you know? So I keep trying to tell them that you're making our job so simple now that it's like unbelievable. So, and this is coming from a person who started PCB design with tape and Mylar. So what I'm seeing now is just unbelievable. So we began our day here by talking about the 2020 Corvette and how that has that 16.2 liter V8, 500 horsepower, 470 horsepower, and going from 0 to 60 in 3 seconds. Or if you're metric, 100 kilometers per hour, 3 seconds. But what if we never shifted out of our first gear? What if we never shifted into what's our next steps? Well, most of all, I think we need to shift the gears in our attitude, how we approach things. I think this is really important of where we're at today as designers, is that we need to shift gears of everything of how we approach this. Yesterday's methods, yesterday's tools are not going to work on tomorrow's designs. They just won't. They will not give us the ability to do that. And I would hope that you will shift your gears in your attitude, because I want to give you one final challenge today. And this is probably one of the most difficult ones to talk about. The reason being is because all the other ones were external. All the other challenges that we're facing were external challenges. This one, this is a little bit more difficult. This is internal. This is about us as designers. It's about you, where you go, what you're doing. And this one is all dependent on you and what you do. You may have external situations and challenges, as we talked about. You know, we talked about the we talked about having the single source of truth through ConcordPro, having the available information for your components through ActiveBOM, having the ability for your HDI designing, of having your layer stack manager and being able to do that. Then we talked about the working with system designs and multi-board designing. All these different tools are available to you. But they are completely useless if you don't use them, if you don't shift your gears. I want to talk to you a little bit because everybody works in 4 different zones. There's 4 zones that you will work. That first zone is the comfort zone. A lot of people live here, work here. This is a place where they feel safe, they're in control. They don't ask them for anything more. Don't ask them for anything. They're in that comfort zone. You can always identify these people, by the way. How? They're the ones that come into the cubicle and say, don't ask for anything. I'm just here to collect my paycheck every 2 weeks and just live my life, be in my comfort zone. Don't ask me to do anything more or anything like that. These are people that have fallen into either a rut in their life, for a lack of a better word, or a situation where a lot of times they don't push out of how they do things. You know, it's sort of like listening to. I can say this because I'm old now, so as my grandkids love to remind me, they love to come up and say, "Grandpa, you're old." I go, "Thank you very much," you know, but you know. A lot of times you get into the mentality where you say, well, wait, this is how we did it, you know. We didn't have school buses. We walked to school. We walked 10 miles both ways, uphill, all the way, in the snow, and we loved it, you know. I'm driving the microphone people crazy here. You know, but it's true. These are the people that sit there and they say, don't ask me for anything. I'm in my comfort zone. Don't push me on anything. There's a second zone outside of that, though. It's called the fear zone. This is the where a lot of lack of confidence comes in. There's a prone to failure. They find excuses and they're easily affected by other people's opinions. These 2 zones is a lot of where I would say a majority of people work and live. And they bounce between the 2 of these. They bounce from the comfort zone into the fear zone. Because then they get kicked into the fear zone and they go, oh, I'm out of my comfort zone, and get back in. Right? These are the folks that you can always identify these folks also. They're the ones that are going around going, what if this happens? What if that happens? All right? Talking to engineers, well, what if this occurs? What happens? What are we going to do? What's going to happen? What if? Oh, living in your fear zone. You see? And unfortunately, if you are going to continue to work in your comfort zone and your fear zone, I can tell you something, the industry is going to leave you in the dust. Absolutely leave you in the dust. Because that's not the direction the industry is going. That's not the direction that Altium is going. I can tell you that there's a third circle outside of that. And that is a place where you rise to the challenges, you deal with the changes and the problems, you acquire new skills, you extend your comfort zone. This is the learning zone. And it's at this point, guys, that you begin to change things. Nothing changes in your comfort zone and your fear zone. Nothing. Everything stays as the status quo, and nothing ever changes, and you get nowhere. Am I being too harsh? But let's chat for a while, okay? Let's just you and me, all right? Right? You will accomplish nothing by working in your comfort zone or your fear zone. Get out of there now. Get out now. Know what your learning zone is. Move into the learning zone. And I want you to notice something, is that if you're going to get to the learning zone, the only way to get from the comfort zone into the learning zone is to go through the fear zone. It's the only way to do it. Don't let fear control you in your decisions. Don't let the what ifs control you. Learn, move into the learning zone, deal with the changes and the problems that you're having, acquire those new skills that you need, and keep moving forward. You keep moving forward. There's a further zone outside of that, and it's called the growth zone. This is where you now take learning and you're growing on what you're learning. This is where you begin to find purposes, you live your dreams, you set new goals, you conquer objectives. And let me challenge some of you. I'm inspired by the young people that I meet in this industry. They understand this principle. They understand this. The ones that I have that have the most difficult time with this principle are those that have been sitting in an office for even a few years, that have lost that whole principle of learning and growing. Learning and growing. I don't care how long you've been in this industry, there's always something more to learn, there's always something more to grow on, and that's where you should be. That's what we need, guys. We do not need more good designers. We don't need them. I'm sorry. Our industry does not need more good designers. We need great designers. You take $100 and you drag it through any country, you can pick up any number of good designers. What we need are great designers. The designers that understand this principle of learning and growth, and they are in that learning zone and they're learning constantly. You know, I think we're in a situation a lot of times where we fear failure. No, don't fear failure. Grasp onto it, hold on to it, because that's where you learn. That's where you truly learn, is through your failures. And when you fail, you pick yourself back up and you keep moving forward. That's where it truly begins. That's where true learning begins, is when you're willing to fail and pick yourself back up. And you continue moving forward. So as a designer, I hope that you understand that the comfort zone and fear zone are going to get you nothing. And where you really should operate as a designer is in that learning and growth zone. This is something I try to teach our designers all the time. Learn and grow. Learn and grow. And the opportunities are there. The material and resources are there. The tools are available to you. Use them. Use them. They're out there. Learn how to use these and grow as a designer. I hope this has been helpful for you today. It's been a pleasure discussing this with you. It's been a pleasure, and thank you, Altium, for giving me this opportunity and to discuss this. Feel free to contact us. If you have any further questions, I'm fully available to any of you to answer any of your questions that you may have. Feel free to get in contact with Altium. They will feel free to get in they will get you in contact with me. It has been an absolute pleasure discussing this with you today. I hope it has been helpful for you. I hope that it's moved you on. I hope it's pushed you forward a little bit as a designer. Because that's really what we're doing here, is helping each other, helping you be a better designer, and that maybe someday what you can do is you can tell us your story and tell us how this has helped you and how it's moved you forward as a designer. I want to thank you all for attending. Thank you very much. I appreciate it. Thank you. Bye.